Hey everybody, this is Mr. Grabo. I'm going to lead you through this Explore number 1. I'm going to get you going on it, and then I'm going to have you finish it up and submit it tonight. So let's go ahead and get started. I'm just going to kind of read through some of it with you and try to explain it along the way. So if you want to grab your highlighter, and we'll just highlight a couple things as we go. So we're looking at geologic time, or the history of the Earth through looking at rocks. And we're going to give you some real common sense examples to help us figure out how did geologists figure out the order of things and looking at the fossils and at the rocks, okay? So we're going to start with this idea of geologic time. Let's go ahead and read through here. How much of your life do you spend thinking about time? Well, for geologists, the answer is a lot. Time comes in different forms in geology, mainly absolute and relative time. They're both important in terms of Earth's history and its geologic timeline, and they work together in concert to build the planet's geologic record. In this lesson, we're going to discuss what each type of time is and why it's important, so you too can understand how they work to describe the past events on Earth. Ready to get started? Here we go. All right, absolute time. So let's start with absolute time. You can think of this type of time as how we normally view it on a day-to-day basis, specific intervals or moments measured in days, months, years, etc. For example, 60 million years is a measure of absolute time. So is 12 o'clock. These are numerical representations of time, and they give us a specific point of reference. We have a long record of events in absolute time, but much of that occurred before humans were on Earth to write it down. So instead of human records, geologists use techniques such as radiometric dating. These processes involve sampling rocks to determine how old they are from their rate of decay. Remember the parent-daughter material? And how we can see how old things are based on how fast that they decay. Okay? Let's look at the next type. The next type is called relative time. Since absolute time gives us points of reference, it helps calibrate relative time. Here, we are looking at events relative to other events. So it's kind of like the order. For example, instead of 12 o'clock p.m., we might say lunchtime. There's no definitive time for lunch, except that it occurs between breakfast and dinner. So relative to other meals, it falls in the middle and is later than breakfast, yet earlier than dinner. That's relative time. This is useful in geology because you can age layers of rock relative to other layers. But instead of saying that one layer is X number of years old, you can simply describe it as older than the layer above it, yet younger than the layer below it. Relative age starts from the bottom and works upwards. Okay, let's start with this generic example. So we're looking at these pictures on the right, and we're going to put them in order of when they occurred. So there's 6 pictures here, and it looks like what happened was, looks like these people are playing with a beach ball, and the dog gets excited, and he runs out, and looks like the dog starts to drown, and looks like the lifeguard picks him up and rescues him. So I'm going to put these in order. Let's see, it looks like the kid brings his dog to the beach. You can see these people playing volleyball in the beach ball in the background. The ball gets loose. The dog runs after it. The dog starts to drown. The lifeguard comes and saves him. And dog is all safe and sound. All right, so we put those in relative time. I don't know what time they happen, but I know the order. And that's what we call relative time. Okay, we're going to use that a lot in geology. Okay, so let's go on to the next example. So we're going to use a locker as our example. So here's a really messy locker. Maybe some of your lockers look like this in middle school. I know I saw a lot of messy lockers like this when I taught middle school. But let's see if we can make some sense out of it using geologic time. So number one, using an arrow, point to the general location of where you would expect to find, and we're going to label them with an A, B, or C. Where would A, the syllabus from the first week of school, where would I find that if I were to look at this locker? Well, I assume that when I got the locker, it was empty, and when I started putting things in, I started putting them in at the bottom. So I would assume that that stuff from the first week of school, like my syllabus, would probably be down here at the bottom. Now, the next thing, a love letter from Valentine's Day. Well, Valentine's Day is in February. That's kind of the middle of the year. So I would assume that maybe that's somewhere here in the middle. And then the last one is end of the trimester grade 3 report card. I would assume that that's probably towards the end of the year. So maybe up here, up towards the top. Okay, so how did I make these assumptions? Number two, how do you make these assumptions? Well, I assume that it was an empty locker, so if I add things to the locker, they would be at the bottom. Newer things, newer items would be towards the top. Okay, number three, which of these locker items would have a definite absolute time or an age and a date that we can connect to it? Well, the one that I'm thinking of is Valentine's Day. I know that Valentine's Day happens on February 14th, so I know at least one for sure date that if I find that love letter from Valentine's Day in here, okay, I know that that happened on February 14th. So the object was that love letter. And the date range, I know that that was February 14th. Okay, so from there, I know that everything below that love letter in my locker was from before February 14th, and everything that was above it or came after February 14th. So at least I have one date of reference in that stack of junk in my locker. And we kind of use that same principle when we start talking about rocks. If we can find a date, then we know things happened either before or after it. Okay, so I'm going to get you started on this next example, and then I'm going to let you loose to figure it out. Here we have our pile of dirty laundry. So number one, determine the order that these clothes were worn to school throughout the week based on their location in the laundry pile. Well, let's see. Monday through Friday, I would assume the first thing that I wore earlier in the week is going to be on the bottom by the floor, and that was my green shirt. Okay, so you can kind of get the idea of how as we lay things down, my pile gets bigger. Okay, so use that same idea, that same principle when you're doing this. Okay, so you want to finish that example. You're going to do another example. If you remember a fidget spinner, we're going to do an example with that. And then we're going to do an example with pizza. And then we're going to kind of bring it together and look at how we can use those same ideas, those same real simple ideas, and put it together and see if we can figure out where the rocks and the fossils go in rock layers. Okay? So give it your best, and when you're done, submit it. And then if you finish early, you can do your third learning target, and that is about absolute and relative time. So after you finish with this assignment, you should be able to answer number 3 in your learning targets. Okay? Good luck.